Welcome to the course on statistics with Python. So before moving to the course, we need to study in detail about statistics because this is the foundation for data science as well as for machine learning. So once only we have a firm grasp on statistics, we can learn machine learning as well as data science. So our first step is to master statistics. Okay. So before delving into the details of this course, let us first see what you mean by statistics. Okay. So statistics is a branch of applied mathematics that involves the collection, description, analysis, and inference of conclusions from quantitative data. So the first step is the data collection. Okay, you can collect some data. Okay, that is the first step. Without data, there is no statistics as well as data science. So once you have data, you need to collect it and you can analyze it and you can make a summary of some of the data and also you can make some inferences. So this is all about statistics. Okay, so based on this process, you can classify statistics into two types, that is descriptive and inferential statistics. So in this course we will study about both descriptive as well as inferential statistics. Descriptive statistics means, okay, that means we will study about that in detail in another video, but let us see, this is basically summarizes data. Okay, so that is all about descriptive statistics. So I will explain what all we are going to study. So in descriptive statistics, we will learn about various measures of central tendencies, measures of dispersion, measures of shape, measures of correlation, etc. And then after descriptive statistics, we will move to inferential statistics. That is the most important part, that is the foundation of machine learning. So in inferential statistics, we will learn about various types of hypothesis testing. Okay, so there are several types of hypothesis testing like parametric and non-parametric. That depends upon the type of data, right? Then, and in hypothesis testing, we will learn about the different types of test. So in parametric testing, we will study about different types of test like one sample test, two sample test, three sample test, etc. And also you will learn about regression. That means you will learn about both linear regression and logistic regression. Okay. And we will use Python to implement this linear regression. Okay. So this is what we are going to study in this course. Okay. Now, once you have understood what all we are going to study and what is some preliminary understanding about this statistics, now we can move to our first step. That is, we need to learn about data. So that means our first step is to study about types of data. Okay, so in the next video, we will discuss about the different types of data. So in the last video, we have seen what is statistics. So statistics is basically a process of collecting and analyzing data to make some inferences. So to analyze data, first we need to see what are the different types of data. So data can be classified into different types based upon its purpose. So let us see what are the different types of data. So this is generally classified into 4 different types. So it's very important to know what are the 4 important types. So these are the nominal data, ordinal data, interval data, and ratio data. So first let us see what is nominal data. So nominal data, let us see that in detail. A nominal scale classifies data into 2 distinct categories. That means an example is, for example, gender. It can be male, female, or transgender. So there is no rank between them. All are equal. Okay, there is nothing you cannot do any ranking, subtraction, multiplication, etc. For example, the marital status, it is either married or unmarried or single. So that is a nominal data. Okay. So when we move to ordinal scale, you will understand it in detail. So this is a nominal data. We don't have much use with nominal data. Okay. And what do you mean by the ordinal data? So ordinal data classifies data into two distinct categories in which you can apply some kind of a ranking. That means, for example, you are asked to enter the product satisfaction level. That is normally we do. Okay, you can rank it as satisfied, neutral, unsatisfied, etc. So there is some kind of a ranking. That means satisfied comes under the top, neutral in the middle, and unsatisfied in the bottom. You can give some numbers also, 3 to 1. Okay, so this is ordinal data because there is kind of ranking between them. So in nominal data, you did not have that kind of a ranking. And another example is faculty rank. For example, professor, associate professor, assistant professor. So there is a kind of a rank between them. The professor being the highest one, and the associate professor being the second highest. Then comes the bottom level, that is the assistant professor. And student grades, it can be A, B, C, D, F, etc. A being the highest, B second. So there is a ranking. So you can establish some kind of a ranking between this data. So all that type of data falls under the category of ordinal data. Now comes the interval scale. Okay, so let us see. So interval scale and ratio scale are the two different types of data that is much useful for a data science student or engineer, data engineer. So let us see what is an interval scale. So interval scale is an ordered scale. Okay, there is also a ranking between them, in which the difference between the measurements is a measurable quantity. Okay, so let us take an example. Okay, for example, year. So let us take the case of year. For example, the year is 1981, and then year is 1985. So there can be difference of 4 years. But what is the true bottom? So you can go back to maybe 0, but you can even go back to BC. Like there is no true bottom. Okay, but there is a ranking, and also that difference also has got a meaning. But in the case of a ordinal scale, for example, if you take the associate professor and assistant professor, there is a ranking between them, but there is no difference. Difference does not carry a meaning. Okay, take the case of a temperature in Fahrenheit and Celsius scale, not in Kelvin scale, because Kelvin scale has a true bottom. In the case of a Celsius, 32 degrees Celsius, 0 degrees Celsius, 0 degrees Celsius is not the ultimate bottom, but the difference carries a meaning. 32 minus 0, that is 32 degrees. Okay, so these are called the interval scales. Okay, now we come to the highest category, or the ratio scale, that is mostly used. It has the maximum use in data science, that is the ratio scale. So ratio scale is an ordered scale. Again, this is an ordered scale in which the difference between the measurements is a measurable quantity, and the measurements have a true 0 point. Let us take the case of a weight. Okay, weight is 20 kg. Weight can be 40 kg, and the true bottom is 0 kg. You cannot go below that. Similarly, age 20, 40, maybe 2, and also there is a bottom, that is 0. Similarly, for salary also. Okay, so these are the different types of data. Okay, so let us see one more thing, that is, okay, So we have seen four different types of data. We can let us call that data level. I told you this is the highest level, that is the ratio, then comes interval, then ordinal, then nominal. So what are the operations you can do with this data? Okay, nominal data you can classify and count. So like that means you classified into male, female, transgender. So there are three different categories. You can just count and classify. You cannot do any other operation. Okay, so later we will learn about some statistical methods. So like parametric and non-parametric. So that comes under inferential statistics. And in that case, if the data is nominal and ordinal, we will use non-parametric methods. And if the data given is interval or ratio, then we will use parametric methods. So we will learn in detail about that in another video when we learn about inferential statistics. Okay, so coming to the ordinal data, you can see here ordinal data we have seen like the product satisfaction level, like satisfied, neutral, not satisfied, like that. So there is some kind of a ranking between them, and you cannot have a difference between them, right? So that means all the above, that is the what all operations you can do. You can classify it, okay, you can count it, and you can rank it. That means this has got the highest rank, this is the second highest rank, this is the third highest rank, like that. You can rank it, right? Now coming to the interval data. Okay, interval data, that means we have seen example of year, that is 1981, 1985, like that. So here you can do, you can classify it, you can count it, you can rank it, and also you can do addition and subtraction. You can subtract it 4 years. The difference is 4 years, it carries a meaning. That means you can add and subtract it. Then comes to the ratio. So in ratio scale, you can do all the operations like classifying, counting, ranking, addition, subtraction, plus multiplication and division. Let us take the case of a weight 20, 40, 50, etc. So you can subtract it, we will get 40 minus 20, 20. If you take the ratio, that is 40 by 20, it is his weight is 2 times that of me, you can say like that. So that operations can also be done. But in this case, 1985 minus 1980, you cannot do that, right? So this is called the data level. So you should know the type of data and the level of the data that you are getting or collecting. Based upon this data only, you can make some inferences or you can conduct some tests, etc. So you can see for interval and ratio tests, you can carry out parametric test, and for nominal and ordinal data you can only have non-parametric test. So in the coming video we will learn in detail about the different types of test. So in the previous video we have seen the different types of data. We have learned about that. Now we are moving to the first branch of statistics that is particularly useful for data science, that is the descriptive statistics. Okay, so what you mean by descriptive statistics? So you have seen there are two types, one is inferential and one is descriptive. So these statistics, they are basically summarizing the data to describe features of the data. So what do you mean by the features of the data? Like central tendency or dispersion. Okay, so these are the features of data. Let us see what are the features that we are going to learn. So here the features means mainly we will study about 3 features, that is measures of central tendencies like mean, median, mode, etc. We will see in detail. Then we will learn about measures of dispersion. So in that you will learn about variance, mean, absolute deviation, range, percentile, quartile, etc. Then you will learn about measures of shape like kurtosis, skewness, box and whisker plot, etc. And then you will learn about measures of correlation. So these are the four measures, the descriptive features that we are going to study. So in the first section, we will move to measures of central tendencies. Let us see that in detail in the next lecture. So in measures of central tendencies, what we are going to learn is to calculate the mode, median and mean of the data. Right. So let us first move to mode. So what do you mean by mode of the data? So this is a measure of central tendency. Okay, that means an indicator of where is the center point of the data. So let us see an example. This is an example. Suppose we have the following set of numbers representing the number of books read by 10 students in a month. Okay, so each value corresponding to a particular student. So that is 3, 4, 2, 4, 5. This is the data. It doesn't make any sense. Let us arrange it. That means you will get it as 1. So 1 appears one time, then 2 appears 2 times, then you have 3 that appears 3 times, and then you have 4 that appears 4 times. Now it makes some sense. You are arranging the data. Okay, so if you want to find the mode, means mode is the number which has got the maximum frequency, which appears the most. You can see that 3 appears 3 times and 4 appears 3 times. So here the mode is 3 as well as 4. You can call it bimodal. There are 2 modes. Okay, so number 3 and 4 appears maximum. It has got the highest frequency. So this is how you calculate mode of a simple data. Now let us go to a slightly difficult problem. That means you are trying to find the mode of a grouped data. Okay, in that case you need a formula to do that. Okay, so let us see one example. So this is kind of a grouped data. You can see here the difference. So here a group of students were surveyed about the number of hours they study per week. The results are grouped into these details. Okay, so you need to find the mode. So this is a interval data. So that means 0, 5. So the frequency is 4, and 5 to 10 it is 7, and 10 to 50 you can see this is the 12. This has got the maximum frequency. So the mode is somewhere between 10 and 15. So you need to find the exact value. So how can you find it? So for this case you can use the formula. So the formula here, we have seen the formula earlier. So the formula is mode is equal to L plus F1 minus F0 by 2F1 minus F1 minus F0 minus F2 into H. Okay, here L is the lower limit. Here it is 10 plus. So f1 is the frequency corresponding to this one. So it is 12. So 12 minus f0 is the frequency of just above. It is 12 minus 7 by, so actually it is 12 minus 7 plus 12 minus the frequency just below. It is 12 minus 9, and the h is the difference, that is 10 minus 15, that is 5. So from here difference is 5. So if you calculate this, you will get it as 13.13. So the mode of the data is 13.13 hours. Okay, this is the time, that is the maximum number of students are studying. Okay, right. So 13 is student, maximum number of students spent some 13.13 hours in study. Okay, so this is how you calculate the mode for group data as well as is simple data. For a group data, you need this formula. For exam, you need to by heart this formula. But if you are using Python, then there are inbuilt functions to calculate the mode, median, etc. So we will do that also. Now let us see what is median of the data. So this is the second feature we are studying in measures of central tendency. So let us see what you mean by median of the data. So let us first take an ungrouped data, that is 83579. Okay, now let us calculate the median for this one. So first let us arrange it in the ascending order. It will be 3, 5, 7, 8, 9. Right. So you can see the middle value here is 7. So the middle value. So here you have the number is 5. There are total 5 numbers. So the middle number is 5 plus 1 by 2. That is 3. Okay, so the third position is the median. So here it is value 7. So suppose the values were like this, 8, 9, 10. So now there are 6 numbers. So in that case, the middle value is it is 6 plus 1 by 2, it is 3.5. That means you need to take the third and fourth numbers, that is 7 and 8. You need to average it. 7 plus 8 by 2, it is 7.5. So this will be this is the median in that case. So if the number is odd and even, the calculations are quite different. So this is how you calculate the median for a ungrouped data, that is the middle value. Earlier we have seen the mode, that is the number which appears the maximum number of time. Okay. So let us take a comparative example. So here suppose 5 appears one more time. So it will be 3, 5, 7, 8, 9. So in this case the mode is 5. Okay, the mode is 5. The median will be the average of 5 and 7. So it will be 6. So median will be 6. So this is the difference. Now let us move to how to calculate the median for the grouped data. So this is an example of a grouped data. Here the interval is given 0, 10, 4, 10, 20, 6, 20, 30, 10, etc. So to calculate the median for this data, you need a formula. So that formula is, let us see that formula. So this is the formula that we are using. So this is the lower limit, and this is the f corresponds to the frequency. F is the frequency of the median interval, n is the total number, etc. Now let us calculate it with the help of this formula. So here we need to calculate the cumulative frequency first. So here this will be 1, and here it will be 6 plus 4, 10, and here it will be 20, and here it will be 25, and here it will be 30. So you can see total number is 30. So the middle value is 15. Okay, we have seen the median position is 15. That means, so since it is 15, so the 15th number will be in this interval, because here are 4, 10. So cumulative frequency is 20. So 15 is between 10 and 20. So this will be in this interval. Okay, so this is your median position. So median position will lie in this interval. Now let us apply the formula. So the so the formula here is, let us do that. Median is equal to L plus n plus 1 by 2 minus f divided by fm into h. Here the lower limit is 20. Okay, so 20 plus this n plus 1 by 2, that is n is 30 here, so it is 31 by 2 minus, so here the frequency will be 10 divided by the class frequency, it is 10. Okay, so this is the cumulative frequency just before the hour interval, so it is 10 here. This corresponds to that, and this 10 corresponds to this frequency. Okay, the 10 in this numerator, it corresponds to the cumulative frequency just before our interval into h, so that is 30 minus 20. Okay, it is 10. So if you calculate it, it comes out to be 25. So 25 is the median value here. It will be somewhere a little more than 25 point something. So you can calculate it. So this is how you calculate the median for group data. So for this data, you can also calculate the mode, right? Then you can compare it. So this is how you calculate the median for group data as well as ungrouped data. So now we are moving to the third measure of central tendency, that is the mean. Okay. So how to find the mean of the data? So that is a central tendency. For example, let us take this example, that is for mean for an ungrouped data. So that means the data will look like this. If you arrange it, it is 5, 5, 7, 8, 10. Okay. So you can see that the median is 7 and mode is 5. Okay, median 7 and mean you can calculate by summing up all these, and then you can divide it by the total number. So it is 15, 25, that is 7. So this is the median. Okay, so you got so this is the mean. So the mean and median both are same and the mode is different, so that is 5. So this is how you calculate the mean of the data. Suppose you have got the salaries of several people, then you can easily calculate the mean, and you can also calculate the median value, and you can also calculate the mode. Okay, so let us take a practical example later. After this video we will see one example where you can calculate mean, median and mode. So now let us move to the median for grouped data. So how will you calculate median for grouped data? So grouped data will appear like this. So you can see it is class interval and frequency are given. So class interval 0 to 10, the frequency is 3. For 10 to 20, it is 5. Like that it goes on. So how to calculate the mean here? So we have seen how to calculate the mode and median. Now to calculate the mean, so here the middle value is 5. So this class interval mean value is 5. For this class interval the mean value is 15 and it is 25 here and it is 35. Okay, so the sum of the total of frequency is 8 plus 8, 16, that is 20. So to calculate mean, you can multiply 5 into 3. So you can multiply this plus 5 into 15 plus 8 into 25 plus 4 into 35 divided by 20. And if you calculate it, you will get the answer as 21.5. Okay, so this is your mean value for this data. Okay, so this is how you calculate the mean value for grouped data and ungrouped data. Now in the next video, we will look at a practical example. So now let us look at a practical example where you can easily understand the difference between mean, median and mode. So let us look at this example. So these are the salaries of of 9 employees given in rupees, that is 15,000, 16,000, etc. So now let us calculate the mean, median and mode. So if you calculate the mean, that means you can sum all these and divide it by 9. You will get the value as 26,556. So you can see that this is the, you will get an impression that this is the average salary. Okay, and let us find the median value here. So the median value, you can see that it is 9. So the position is 9 plus 1 by 2, it is 5. So it is 18,000. So median is 18,000. And what is the mode? So So the mode value is here. So it can be 16,000 as well as 18,000. It is by model. Okay, so this is, so all these measures, some kind of a measures of central tendency. That means you can get an approximate idea of where the middle value lies. Okay, what is the average salary, what is the median salary, what is the mode. More number of people get 16,000 and 18,000. Right. So sometimes it can be misleading. Sometimes the salary can be like this 10,000, and so many people will get 10,000, 20,000, 15,000, etc. And there are some people who are earning 10 lakh. Okay, so in that case you can see the median will go up. Okay, so you will get an impression that okay, the median value, for example, for in a company, the CEO is getting maybe 1 crore, and the people, the all other employees are getting some 10,000, 20,000. So if you calculate the mean, you will get an impression that okay, the average salary of the employees in that firm is some maybe 1 lakh or 2 lakh, but it is not so. Then you need to look at the mode. What is the salary of the number of people, lot of people there. So it comes out to be some 10,000 or 50,000 like that. And what is the median? You can also calculate the median. What is the middle value? So it will also be some 20,000, 30,000, etc. So you will get a picture of the situation there. Not really. So that means you need to calculate median, mode, and also mean. Then only you will get an idea about the center. So welcome back to another session. In this session, we will revisit everything that we have studied in descriptive statistics, like measures of central tendency, measures of dispersion, measures of shape, etc., with the help of a Python example. For this purpose, I have downloaded a sample set from Kaggle. Okay, you can get this data set from Kaggle. You can search for student performance in exams. I will also upload that in our course. So I have downloaded that, and I will show that. So this is our data set. Okay. So I am going to make use of these descriptive statistics to get a idea about this data. So what does this data say? So these are the scores of students. You can see the math score, reading score, writing score of different students. It can be male or female, and from different races and ethnicities like group B, group C, etc. And some other condition like parental level of education is also taken, like bachelor's, if the parents have a bachelor's degree, etc. Whether also a data set column corresponding to lunch and test preparation, etc. Right? So I am taking here the math score. Okay, so you have a lot of data here. So I am taking this particular data, that is the math score of the students, and I need to find out what is the median, what is the average score, what is the mode, okay, what is the variation among these scores, etc. So all this data, right? So these are the measures of central tendency, dispersion, shape, etc. So first let us use the Python code here. Okay, I am using this Python code, right? Okay, so we are going to some practical example. So throughout, I am going to introduce you to pandas. Throughout the course, it will be beneficial for you. So I am importing this pandas library as PD. So this pandas library helps us to extract data and visualize data. That means you can import a CSV file. So this command, I am using this command, that is pd.read_cfv. You have a command for Excel also. I am importing this file, that is course.csv. I am storing this file in the same folder as that of my Jupyter notebook. Right. So I have created a data frame. This df is called a data frame. So let us print that data frame first. Okay. So you can see the data around, they have collected around 1000 samples. So these are the columns like gender, race or ethnicity, parental level of education, lunch, and test preparation course, math score, reading score, etc. Right? But for this example, I need only the reading score. Okay, that I need the math score. This column is the math score. So for that, I will take only math score. This is the column. If I am giving the column name, I will get, so now I don't want the df to be printed, I just the math score. See, I have extracted these values like 72, 69, 90, 47, 46, etc. Okay, so this is the first step. That means I can extract the data. Right. Now I need to find out what is the mean, median and mode. So let us look back at our formulas or the Python code for mode of data, median of data, mean of data, etc. You have a ready-made formulas for that, or ready-made Python code. Here, just let us paste it here. Okay, so let us find the mode first. So here the data is df max score. Okay, df max score. So you can find the mode. So here I am using, okay, I need to import statistics. Right. Okay, this is the mode is 65. Similarly, let us find the median. The median. So what is the median value is 66. And what is the mean? Okay, let us find the mean, and the mean is 66.089. So you have got an idea about it is close, right? It is, you can see that the mean, median, mode, etc. are quite close. Right now, so once we have found out the mean, median and mode, let us find the measures of dispersion. Okay, that means that is the standard deviation. Okay, so that is the measures of dispersion like variance, mean absolute deviation, range, quartile, etc. So let us plot that. Okay, for that, let us look at the formula here. So for standard deviation, So for can use this formula. Right. Okay. So here the data is the math score. I need to put that here. Okay, just try to print it. So the population standard deviation is 15.16. You can also find the sample standard deviation. Now let us find out the quartiles. Okay, so I'm using this formula, the quartiles, that is where the what is the first quartile, second quartile, third quartile, etc. You can see it here. So here you can do one thing, just put a data is equal to df mass score. Okay, let us find the quartiles. You can see it is 57, first quartile is 57, second quartile is 66, and third quartile is 77, and the interquartile range is 20, right? So you have got the quartiles. Now let us plot the box and whisker plot. Okay, look at the where was the okay, see, this was our box and whisker plot code. Okay, now just find it. Okay, let us plot the box and whisker plot. Okay, now you get an idea about the data, right? There are several outliers you can see. You can see from this box and whisker plot, the median and mean. So there is not much skewness, but there are a lot of outliers. A kind of left-tailed, you can see. So from this box plot you can find out the outliers and where the most of the values lie between, you can see around 58 to between 79, right? So the interquartile range is 20. So you have plotted the box and whisker plot. Now let us find the skewness also, right? So this is the formula for the skewness. Okay, let us print the skewness value. So you can see it is minus 0.27. So that means it indicates it is left skewed. Okay, slightly left skewed. You can see there are several outliers here. That means it is slightly left skewed. Right. Similarly, let us find the kurtosis value also. Okay, let us look at the example. So kurtosis, this is the formula. Okay, let us paste it here. Right, the kurtosis is 0.275, is greater than 0. So it can be leptokurtic or mesokurtic depending upon the value. That means it can have a flatter tail or longer tail, etc. You can refer to the kurtosis diagram. So based upon this value, you can predict the shape of the distribution. So this is how you are doing descriptive statistics. To get an idea about the data. For this particular case, I have taken only, let us print that df once more. See, I have taken only one column that is corresponding to the math score. Now I can take the reading score and find the average. I can find the writing score, you can do that, and then you can make a comparison. Also, after some lectures you can pick some a particular gender and find the scores. You can compare it with a scores of male students, and you can do some statistical test. Okay, so that will be we will examine that session. So investigate that after some more lectures, right? That is what we are going to do.